Alright, moving on to number 3. This one has a situation where there's a tournament, it starts with 64 combatants, and then every round half of them get lost, so 32, 16, 8, so on and so forth. I guess I could really finish this out. Once you get to 1, you actually can stop, because once you reach 1, that's when the tournament's over. You have your champion here at 1. Okay, anyway, so here I notice that I'm halving it every time, and so my common ratio is going to be 1/2, and my start value is 64, so I got the 2 pieces of information I need. We got a sub n equals a sub n minus 1 times 1/2, and then a sub 1 is 64, so there's our recursive function. The explicit function is going to follow the geometric explicit function pattern that you have in your notes there, and so write it out like that. The decay rate is the percent that you're losing between each iteration, between each number in the sequence. Well, we're losing half of them, so the decay rate is 50%. Number 4, this one, people got a little bit confused here on this one, because it's not like you start with 5, and then people got thrown off by the every 10 minutes thing. Here, the start number is in this sentence here, right here at the end. Jenny cleans her phone, and she leaves 5 of them, okay? When you guys, like, sanitize stuff, you got your hand sanitizer, your wipes or whatever, they don't kill all the germs. Notice how it says 99.9% or something like that. You don't kill all the germs, and so Jenny tried but didn't get them all. There's 5 to start with, and they double every 10 minutes. And so we're not going to worry about like the minutes conversion thing. We're just going to say it doubles every time. And when I say every time, that just means every 10 minutes. So we got a R, a common ratio of 2, and a sub 1, a first number of 5. Okay, so we got the important information to write our functions. A equals a sub n minus 1 times 2. And then a sub 1 equals 5. And that's the hideous 5. The explicit function is f of n equals initial value times your common ratio to the n minus 1 power. And then, what is the growth rate for every 10 minutes? Well, luckily that's asking about the same units every 10 minutes. So our growth rate is going to be 100%, because we're increasing by 100% every 10 minutes. Number 5, this one they're unpacking yearbooks out of a box, so they're taking them out. And I notice here I have a common difference of 11. So there's our common difference, so that's going to be our D. And I have an initial value of 281. I got the information I need. So a sub n equals a sub n minus 1 minus 11. I guess I should have put my common difference of negative 11 because it's going down. And then my a sub 1 is going to be 281. The explicit function would be f of n equals negative 11 times n minus 1 plus 281. Okay, and then it's asking how many yearbooks are in the box. Well, you can take the total weight of the box to start with, 281, and divide by how much each one is weighing, which is 11. And then you're gonna get a little fraction here. And the reason you're getting a fraction is because the box itself actually weighs something. And so you're gonna have a little fraction that's like 25.5454 repeating. And so would it make sense to round up or round down? Well, you wouldn't round up because that'd be more weight in the box than that's actually there. You'd round down because the extra amount, the 0.5454 repeating that's in your decimal, here, I'm gonna write this out real quick. The extra decimal part is the weight of the box itself. And so you have to round it down to 25. So that's 25 yearbooks. Alright, and we'll jump on to number 6. After a recent knee surgery, I had to get back into my program slowly, so I started with 12 minutes in the first week, and then added 6 minutes every week. So this add 6 minutes every week, that's my common difference. If I write out my sequence, I would start with 12, and then add 6, and then add 6, and my pattern would continue. And my initial value here is 12. So I got the important information to write my functions. A sub n equals a sub n minus 1 plus 6. And then a sub 1 is 12. The explicit function follows the same pattern we've been using since last week. Whoops. 6 times n minus 1 plus my initial value. And so I got my two functions here. And it's asking how many weeks will it take before I can run a half marathon again. And that's 120 minutes. Well, this pattern is going to keep continuing, right? Adding 6, add 6, add 6. Well, I want my final amount to be 120. That's the same thing as, that's what f of n stands for, is how long I've run. And so I'm going to replace f of n with 120. And then I need to find out what my n is, the number in the sequence. Okay? Remember, n is the number in the sequence, not necessarily how many weeks there is. So I need to do a little bit of solving. I'm going to subtract 12. I'm going to get 108 equals 6 times n minus 1. I need to divide by 6. So it's going back to our beginning of the year type stuff. And I need to do a little bit of solving. Here, 108 divided by 6 is going to be 18. And then you add 1 to finish up. So that's going to be, whoops, that's not 18. That's 19. Because 18 plus 1 is 19. So that's what n is. And n is the number in the sequence. That doesn't mean that's the week it is. Because here, here I start here at 12. And that doesn't mean, okay, so that's the first week, but that's not how many weeks have passed. It's asking how many weeks it will take. Well, you don't count the first week. And so I need to take away 1 here for it to correspond to how many weeks it takes for me to get up to the 120 minutes there, okay? So it's going to take 18 weeks because I had to shift over 1.